Hi guys, welcome. Today we are going to learn about working with the DC motors, and it was an important topic, so I thought I should include this. So today we are going to learn how we can use our nRF devices to control DC motors, and we are going to use a L298 driver, which is basically an H-bridge driver. If you are directly seeing this DC motor control tutorial, I recommend you to watch my previous tutorials on the PWM and get a grip on working with the PWM, then come to this tutorial. So today we are going to learn about this, so let's see how we can use a driver to control a motor. So what is L298? L298 is basically a dual H-bridge motor driver, and it can be used to drive two DC motors at the same time. It supports a wide variety of voltage range, and the recommended range is 8 to 36 volts. I will let you know how we can use this, and of course it can be controlled with our nRF device, and we are going to use a logic level of 3 volts. By using the L298 H-bridge, we can control the motor's direction and of course the speed as well. Using this H-bridge driver, we can increase or decrease the DC motor speed, and we can also control its direction as well. So it's been mostly used in the robotics, so I thought if you have some project related to robotics, this would be useful for your project. So let's get started. So first of all, we are going to see the basic circuit. So I'm going to draw that circuit on a paper, and you are going to see how we can connect the wirings. And then we are going to program it. Okay, we have this L298 H-bridge dual motor driver, and we are going to use this module for controlling the DC motors. And I'm going to put the link in the description, and you can buy it from that link. If you haven't used this driver before, don't worry, I will explain everything about it, so you don't need to worry about it. But you have to be very careful with the wiring, because if you make a mistake in wiring this driver, it's going to burn your microcontroller, because here we are going to use a higher voltage level which are not suitable for nRF devices. And of course the control logic is just 3 volts, but if you connected a wrong wire by any mistake, this is going to cause your microcontroller to get burned. Here you can see we have 3 pins here. The first pin here, the first pin is the 12 volts pin, the second pin is the ground, and by ground I mean the negative voltage pin, and this is the 5 volts pin. So these 2 pins are for motor 1, and these 2 pins are for motor 2. So we can connect 2 motors with this, 2 DC motors with this, and we can provide them the power from here. For example, our motor is working with the 5 volts, then we can provide the 5 volts here. This is the ground, and this is for higher voltages. For example, if we are using 12 volts, we can use this side. It also has an internal regulator as well, which regulates the voltage to 5 volts. So if you are providing a 12 volts and you need to provide 5 volts to your circuit, you can use this regulator's power, and you can get the 5 volt output here as well. Okay, so it has many features. The first feature is it has two output connectors, so we can connect 2 DC motors. It can be connected with either 12 volts, 16 volts, or any voltage higher than 12. You can connect with this pin, and if you have a lower voltage like 5 volts, then you can connect it with this pin. And this is the ground pin, and keep in mind that we have to connect the ground pin with the microcontroller's ground as well. Make sure you connect your device's ground here as well, otherwise it's not going to work. So let's draw a simple circuit to see how it works. So this first pin is for 12 volts or greater. So if you have any motor with the greater voltages, for example 12 volts or 16 volts or 20 volts, you can use this. And make sure the maximum limit is 50, but make sure you don't use over 36 voltages. And the second pin is the ground pin. So this is the ground pin, and we have to connect this ground. This ground is basically the negative pin. So if we have a battery, for example I am using a 12 volt battery, I will connect its positive terminal with this, and I'm going to connect its negative terminal with the ground. Okay, and now we have to connect a motor. So for the motor we have, for example, I have this motor, and I have two connectors here. So first pin is going to be connected with this one, and the second pin is going to be connected with this. So here is the motor connection, and if you are using a motor with the 5 volts, then you can provide the 5 volts from here. You don't need to provide higher voltages. For example, if you want to provide 5 volts, then you can just directly use this, and you can provide 5 volts here and the negative terminal with the ground of that 5 volt power. For example, if we are using a 5 volt power supply, then this is going to be its circuit. And if you are not using 5 volts, then omit that, and we are going to leave it. In our case, we are not going to use the 5 volts, so we are just going to use the 12 volt. I'm going to drive a big DC motor, and now here is the important part. We have 6 pins here, and the 2 pins are already connected as a jumper, and we will see their function later. First of all, let's see the 4 pins, the internal 4 pins, which are IN1, IN2, IN3, and IN4. So these 4 pins are for 2 different motors. So for example, IN1 and IN2 are for the motor 1. So if I provide a logic 1 here and logic 0 on this pin, then it's going to rotate the motor clockwise. And if I provide here logic 0 and logic 1 here, it's going to rotate the motor anti-clockwise. So this is a very useful function, so we can change the direction of the motor by just providing simple logics on these 2 pins. And the other 2 pins are for the second motor, and they work in similar ways. So we can provide logic 1 and 0 or 0 and 1 to rotate clockwise or anti-clockwise. Okay, and here we can connect another motor, which can be any other motor, and here we can connect the other motor as well. So this is motor 2. Today we are just going to see one motor connection, and we are just going to connect that motor here, and we are going to use IN1 and IN2 pin to change the direction of the motor. And now we are going to see what's the function of these jumpers. So these jumpers are the enable pin. So if we take this jumper out, now this motor 1 is not going to work because this pin enables the motor to start working. So if we take out the jumper, it's not going to work. So what are we going to do now? We have 2 pins here. The upper pin is the voltage level pin, so we are not going to use that. This second pin is the pin that is important for us. It's ENA, which is enable A pin or enable motor 1. So I don't have any space here, so I'm just going to draw this like this. Okay, so here we have connected an ENA pin, and this ENA pin is going to be connected with the PWM. So using the PWM, we can control the DC motor's speed with this ENA pin. So for example, if I give 100% duty cycle, then this motor is going to work at the full speed, and if I'm going to give it 50% duty cycle, then the motor speed is going to decrease. And similarly, if I reduce the duty cycle, the motor speed is going to reduce, and if I increase the duty cycle, the motor speed is going to increase. And we can use these IN1 and IN2 pin to change the direction of the motor. So I hope so this is enough for the basics, and don't mess up with the wirings. We are going to use IN1, IN2 and ENA pin with our nRF device, and make sure your device's ground is also connected with this ground, otherwise it's not going to work. So make sure you connect this ground with the device ground. So nRF, make sure your nRF device ground is connected with this pin as well, otherwise this logic voltage or this PWM signal is not going to be recognized, it's not going to work. So make sure you connect this ground pin as well. I'm just going to connect the wires now, and then we will start programming. Okay guys, the wiring is completed, and now we have to create a new project. So first of all, I'm just going to create a new project. So go into this PC, in the C directory we go into the nRF SDK. Here in the examples, just go to my projects and copy this timer software and paste it here, and let's rename it. We are going to use the hardware timers this time for the PWM. We are not going to use the PWM directly, we are just going to use the hardware timers because this library code is shorter and it's good for the DC motor control. Of course, later on when we are going to see the stepper motors, then we are going to use the PWM directly, and now we are just going to use the hardware timers for that. So open this project and go into the PC10040 if you are using nRF52832. Open the blank, open the SES folder, and open the. Once the file is opened, here we have the previous code. So we are just going to modify this. So first of all, if you know about the PWM, then you can just directly see the hardware timer library tutorial, and if you have directly seen this tutorial, then please, I would recommend you to watch my PWM tutorials all in the series and then come to this tutorial, because you are not going to understand if you haven't seen my previous tutorials. So we are just going to modify this code, so let's start modifying it. So I'm just going to zoom in a little, and let's remove this, and here everything is okay. So let me just mention the connections. So we have connected our enable pin, which is the PWM pin, to pin 22, and we have connected the IN1 pin to pin 23, and we have connected the other IN2 pin to pin number 24. And we are going to change this frequency to 100 microseconds. It shouldn't be too high and it shouldn't be too low, so I'm just I'm using 100 microseconds frequency now, and all this handler code is going to remain the same. Everything is same, just we have to change here the pin name, because here we are using the motor. So I'm just gonna define the motor pin, which is connected with the PWM. If you are new with this code, just you make sure you start watching from tutorial 27 and onwards, and when you come to this tutorial you will be easily able to grasp the concepts and everything. So to indicate those states, I'm just going to use the LEDs. So okay, so the first thing is I have to turn on the LED to show the first state. So for that, I'm just going to turn on an LED, and I'm going to use a simple function. And let's say LED 0 should turn on. Let's say it's going to run at 40% duty cycle, because I'm just going to use 100 microseconds at the frequency. So for 40 microseconds, it's just going to remain turned on, and for the other 60% it's going to remain off. So we will see for this duty cycle how much the speed the motor gains, and then I'm just going to turn off the LED. I will use two DC motors. First time I'm just going to use a fan which just rotates in the one direction only, but we are just going to see its speed, and then I'm just going to use another motor to show you the change in the direction of the motor. Let's initialize these pins. And now let's set the direction of the motor. So I have set the direction of the motor by changing the states, logic states here. So I have set the direction of the motor. So for example, if I give logic 1 here and logic 0 here, the motor is going to rotate clockwise. And if I give logic 0 here and logic 1 here, the motor is going to rotate anti-clockwise. And with the PWM, we are going to increase or decrease the speed, and by this way we can control the robots and robot cars and many other stuff. So we have to modify this code a little. I'm just going to say for 0, when it's set to 0 for the active high, the fan is going to work at 100%, and if I set it to 20, the fan is going to slow down a little bit, and then if I set 40, it's going to slow more, and at 60 it's going to be more slower, and at 100 it's going to stay off. So let's build it. Make sure your device is connected, so we are connected with the device, and erase all, and then let's download it and see what happens. So here you can see I have set it to 0, so it's the first condition, first state. Now the fan is slowing down because I have changed the duty cycle. I have changed another duty cycle and it's more slower, and in the last step is the least slow. Here you can see it has turned off, and now so let's change the program a little bit, and this is for example, this is the clockwise, so I'm going to set the motor for the clockwise. So let's give it 3 different duty cycles to see the change in the motor speed, and then we are going to change the direction and then again we are going to use this same code, and it's going to be fast, slower, and let's say the least, let's say it should turn off, and let's set it to 50%. Save this, make sure your device is connected, and let's build this. Okay, the code is built and motor is connected, so let's connect with the target, erase all, and download this new code. And here you can see the motor is moving at a faster speed, and now it's getting a little slower because the duty cycle is 50%, and now it's turned off, and now it's going to change the direction. And here you can see now the motor is moving clockwise, and it's slowing down, and then it's going to turn off. I hope so you have learned something new today, and the code along with the description is available for download. For now, I think so this is enough, and I hope so you have learned something new today. And if you are new to my channel, please be sure to subscribe to my channel and hit the like button if you like this video. And thank you very much for watching. See you in the next video.